Hello everyone, a very good evening to all. I welcome you once again to the introduction session on atomic and molecular physics for January 2023 session by NPTEL. I am Vivekananda Naik, a Prime Minister Research Fellowship Research Scholar in the Department of Energy Science and Engineering, IIT Delhi. So today I will be discussing problems which will be based on week 11 and week 12 lecture of the atomic and molecular physics course. So let's start with the first problem of the day. So in previous class we had solved a few problems regarding the rotational spectra of the molecule. So we will continue with that. Then we will proceed towards vibrational and Raman spectra. So the question is, what is the change in rotational constant when hydrogen is replaced by deuterium in hydrogen molecule? So here what we have been given from the question, it is what is the change in rotational constant V. So we have to find the change in rotational constant V when hydrogen is replaced by deuterium. When hydrogen replaced by deuterium in hydrogen molecule. So what we have been given, here we will calculate the change in the rotational constant value when hydrogen replaced by deuterium in the hydrogen molecule. We know in hydrogen molecule what we have. In hydrogen molecule what we have two hydrogen atoms uh, connected to form a hydrogen molecule. So in hydrogen molecule what we have, sorry my mouse is not working properly. So in a hydrogen molecule we have two hydrogen atoms that are we have two hydrogen atoms, it is H and S. They are bonded with some, they have a certain separation which is the bond length, and there are two hydrogen atoms to form a molecule. But when you replace one hydrogen atom by a deuterium, then what will be the change in rotational constant? So when you replace this hydrogen atom by deuterium, that is D, and you know hydrogen is 1H1, but deuterium is 1H2. So the mass of hydrogen and deuterium both are different, and we know that the rotational constant V depends upon mass, because what is the expression for rotational constant? Rotational constant V is equals to H divided by 8 pi square IC, where what is I? Where I is moment of inertia, it is mu r square. So I is mu r square. This I is mu r square, that is moment of inertia, which is mass into the distance of separation square. So when you replace one hydrogen atom with deuterium in the hydrogen molecule, Then the here mu is the effective mass, and this effective mass is going to be changed due to the introduction of deuterium in place of hydrogen. So here we will calculate the change in the constant d. So first, let for hydrogen, like for like when both are hydrogen, then in that case what will be B? Suppose we write it at BH, then what will be BH? Then BH will be H is a constant, so it has nothing to do with the type of atom. 8 pi square I we know I will be depending upon the mass, so we can represent it as IH and then C. So this is for hydrogen or hydrogen in a hydrogen molecule. And now we will consider about the situation when the hydrogen is replaced by deuterium. So when you introduce deuterium, then what will be the value of B? Then the value of B will be, suppose when we deuterium introduce, it is BD. BD equals to H divided by 8 pi square IDC. So if you compare the two values, sorry, so here the I write it one second. Suppose there are two hydrogen atoms and you want to change one hydrogen atom to deuterium. So this will be D, then it will be converted to DH, then what will be the change in the rotational constant. So we know what is the value of B. The value of B is V, which is rotational constant, and its unit is length inverse, or we can say centimeter inverse. Then it will be H by 8 pi square I into C. So this is the expression for rotational constant. And if you consider about hydrogen, then for hydrogen rotational constant, suppose we represent it as H, BH, then BH will be H divided by 8 pi square IHC, where IH is equals to mu h r square, because we know I is the moment of inertia and it is equals to mu r square, and mu is the reduced mass and r is the bond length or distance separation between the two atoms in a molecule. So similarly for deuterium, what will be the expression for rotational constant? Then the rotational constant expression will be h by 8 pi square id into c. So here id is how much? Here id is mu d r square. So but here we know hydrogen is 1h1 or deuterium is 1h2. So in this case the mu h and mu d will be different. So when you take the ratio of the two, then what you will get? B hydrogen divided by B deuterium is equals to B hydrogen and B deuterium is equals to ID by IH, because B is inversely proportional to I, so it will be ID divided by IH. And we know I is that proportional to mu, so it will be mu D by mu H. So here what we will calculate? We will calculate the ratio of the effective mass of the two molecules. In one molecule there is one deuterium connected to one hydrogen, and in another molecule two hydrogens are connected. So this difference will give the change in the value of B. So when you calculate the effective mass for deuterium, we know for hydrogen case, that is when both are hydrogen, then what will happen in that case? When both are hydrogen and hydrogen, then effective mass will be how much? Mu H will be mh into mh, mh into mh divided by mh plus mh. Then it will be how much? It will be mh by 2. But when there is one D and one H, one D, one deuterium and one hydrogen, in that case, that will be the deuterium. It will be Md into Mh divided by Md plus Mh. And we know the mass of deuterium is twice the mass of hydrogen, so it will be 2mh into mh divided by 2mh plus mh. So what will happen in that case? In that case, the effective mass will be 2mh square divided by 3mh, so it will be 2 by 3mh. Will be 2 by 3 mh. So in one case it was half mh, but in one case it is 2 by 3 mh. So the ratio of Bh by Bd will be mu d by mu h. So mu d is 2 by 3 mh and mu h is half mh. So Bh by Bd will be how much? So uh, am I audible to you? Hello, am I audible to you? So basically, we are discussing the first problem of today's session, and the problem is will be the change in rotational constant B when the hydrogen is replaced by deuterium in the hydrogen molecule. And we know in a hydrogen molecule there are two hydrogen atom connected. So when there will be one hydrogen atom will be replaced by one deuterium atom, then the molecule will be like that. Deuterium is connected to hydrogen. In that case, what will be the change in B? that of the case when there were two hydrogen atoms. And we know the expression for rotational constant is h by 8 pi square ic, where I is the moment of inertia and moment of inertia is given by effective mass into distance square. So the moment of inertia for h, in the case when both are h, and in the case when one is d, will be different because there is effective mass included in the expression of I, and this rotational constant v also depends upon I. So in that case, if you take the ratio of the two b's, that is two rotational constants, then the ratio of bh by bd will be, since the rotational constant is inversely proportional to moment of inertia, so bh by bd will be id by ih, and the ratio will be mu d by mu h. So when you calculate mu h, it will be mh into mh divided by mh plus mh, because effective mass is m1 into m2 by m1 plus m2. So mu h will be mh by 2, but dh will be md into mh divided by md plus mh. So md is 2mh, so 2mh into mh divided by 2mh plus mh, so it will be 2mh by 3. So in that case, what will be the ratio of bd bh by bd? So bh by bd is equals to, bh is mh by 2, sorry, bh by bd is mu d by mu h, mu d is 2mh by 3, so 2 by 3 mh into mh by 2, so it will be 2 by mh, 2 by mh. So mh gets cancelled out, it will be 4 by 3. So bd will be 3 by 4 mh. So this bd will be 3 by 4 mh. So what is the change in b? So the change in b will be, initially it was only b, that is, so it will be 3 by 2, sorry, it is not mh, it is bh. So it is bh. So bd is equal to 3 by 4 bh. So initially it was bh, and the change and it is changed to bd. So what will be changed? It will be bh minus 3 by 4 bh, which is equals to 1 by 4 bh. So the difference, that is the change in b, is 1 by 4 bh when the hydrogen atom in hydrogen molecule is changed to deuterium. So is it clear to you what I explained in this problem? Is it clear to you, or I will explain to once again? So uh, this problem, can we can solve this type of problem in another way. So suppose suppose I suppose in question it was given that, uh, the question we recently solved is, when the h is converted to d, but what will happen when this h is converted to d d, then what will be the change in rotational constant? So please calculate it and tell me what will the value. Like in this case, the change was 1 by 4 bh when we changed only one h to d, but when we change both the h to d, then what will be the change in rotational constant? So please solve this. I'll give you a few minutes, then I will solve it. So please calculate and tell me what will be the answer. What will be the change in B when both the hydrogens are replaced by deuteriums? I have 4BH, so I don't think so. Let me calculate it. So when we calculate, what will be the change in this case? In the previous case, mu h and mu d, mu h was mu h by 2, so it will be mu h was mh by 2, it will be same, but here it will be changed. So when we solve it, so when we solve it, then what will be the, we found the effective mass for hydrogen, when both are hydrogen, that is mh by 2. Similarly, in this case it is mh by 2, both are hydrogen. So in this case it will be md by 2 since both are deuterium. So mu d will be md by 2. So but here mass of deuterium is twice the mass of hydrogen. So when you put it, md will be 2mh by 2. 2 gets cancelled out. It is mh. So effective mass of hydrogen molecule when both are hydrogen is mh by 2, but the effective mass of deuterium when both are deuterium is equals to mass of hydrogen, that is the half of the mass of deuterium, and we know deuterium is twice that of the mass of hydrogen, so it is only mass of hydrogen. So what will be the change in B then? So BD will be how much? BD will be here, BD was here, the so BH by BD. So the ratio was BH by BD equal to MD by MH. So BH by BD will be mu D by mu H. BH by BD equals to mu D by mu H. Mu D is MH by mu H. Mu H is MH by 2. Note it. Mu D by mu H. Mu D is MH, but mu H is MH by 2. So it is MH divided by MH by 2. So it will be how much? It will be 2. So BD is BD by BH will be 1 by 2, or BD will be BH by 2. So what is the change? So the change in B will be BH minus BD, that is BH minus BD, which is equals to BH minus BH by 2, which is equals to BH by 2. So this is the answer. I think it is clear to you. But do you have any doubt regarding this? Is it clear to you now? So the answer will be BH by 2, because when both the hydrogen are being changed to deuterium, then in that case the effective mass of deuterium will be the effective mass of deuterium will be equals to the mass of hydrogen. So the ratio of BH by BD will be twice. So the value of BD will be half of the value of BH. So from BH, when we subtract BH by 2, it will be BH by 2. So the change in the rotational constant in question it was given. What is the change in rotational constant when hydrogen is replaced by deuterium in the hydrogen molecule? So when we replace one hydrogen with deuterium, the change will be 1 by 4 BH. This is the change. But when we replace both the hydrogen by deuterium, in that case, the change in B will be BH by 2. So I think it is clear to you now. We can proceed to the next question. The next question is, what is the average period of rotation? What is the average period of rotation of hydrogen chloride molecule if it is in the J equals to 1 state? The internuclear distance of HCl is 0.1274 nanometer, and given the mass of the hydrogen and chlorine atoms are 1.67 into 10 to the power minus 27 kg, and mass of chlorine is 58.06 into 10 to the minus 27 kg respectively. So we are given with the mass of hydrogen and chlorine here. The mass of hydrogen, this is the mass of hydrogen, and this is the mass of chlorine. So both the atomic masses are given. We want to calculate the average period of rotation of HCl molecule. So for average period of rotation, what we need, we had solved this type of problem in the previous session. We will calculate the rotational energy first. Then from that rotational energy, we will calculate the we know the rotational energy can also be represented in terms of like the kinetic energy we are representing. Kinetic energy equals to half mv square. So the rotational kinetic energy can be also given as half I omega square. So from that we can calculate the value of omega. So first we will calculate the rotational energy from the rotational level j equals to 1, and then by equating the energy to the rotational energy of half I omega square, we will calculate the value of omega, and omega is the omega is angular frequency, so the average time period will be calculated from omega. So how we will proceed? So first we know, in case of the rotational energy in terms of J, rotational energy will be given. The rotational energy is how much? It is h cross square by 8 pi square I j into j plus 1. So it is h cross square, sorry, it is h square only. So it is h square by 8 pi square I j into j plus 1. So this is the rotational energy for a rotational level j, and in question it is given the state of the value of the j is j equals to 1 in the molecule, the HCl molecule is present in j equals to 1 state. So when we put all these, we can find the value of E. But again, this E is equals to half I omega square, half I omega square, because this is rotational energy, and rotational energy is also given as half I omega square. So when we equate the two energies, then what we will get, half I omega square is equals to h square divided by 8 pi square I j into j plus 1. So when we equate it, then we can calculate omega. Then what will be the value of omega? Then omega will be, so omega square first we will found. Omega square will be h square j into j plus 1 divided by 4 pi square I square. So this will be the value of omega square, and by taking the root of that, we can calculate the value of omega. But before calculating the value of omega, so let's calculate omega. Omega will be the root over of h square is h. It will be 2 pi I. It will be h by 2 pi I j into j plus 1 root over. So, to calculate omega, we need the value of I, value of h, pi, and j. We have the value of j because in question it is given the atom, the molecule is present in j equals to 1 state. So, j equals to 1 we have. We know the value of h, we know the value of pi, but we don't know the value of I. So, how we will calculate the value of I? We know I is mu r square, that is the moment of inertia is equals to effective mass into the bond length or distance of separation. So first we will calculate mu for HCl and then we will multiply r square and we will calculate the value of I. So here for calculating mu we have the mass of H and mass of chlorine, mass of hydrogen and mass of chlorine, and the separation between them is 0.1274 nanometer. So R is 0.1274 nanometer. So mu will be how much? Mu HCl will be mass of hydrogen into mass of chlorine divided by mass of hydrogen plus mass of chlorine, and I will be the value we will be getting here into 0.1274 nanometer. So 0.1274 nanometer means 10 to the power minus 9 square, and the unit will be kg into meter square. So we know the value of mh and mcl. Then please put the values of hydrogen and chlorine mass and calculate what will be the value of moment of inertia of I. Moment of inertia I of HCl. I'll be waiting a few minutes for your answer. Then I will solve. So when you put all the values, then the value of I will be 2.639 into 10 to the power minus 47 kg into meter square, and by putting the values, omega will be h by 2 pi I. Omega will be h by 2 pi I into j into j plus 1. If you put j plus 1, then it will be 1 into 2 root. So it will be root 2. So h 2h divided by 2 pi I. So root 2, that is 1.414 into h, 6.62 into 10 to the power minus 34, because we are doing it in kg into meter square, so it will be in terms of joule into second. So in joule it is 10 minus 34 divided by 2 into pi is 3.142 into I is 2.639 into 10 to the power minus 47. So when we calculate it, it will be 5.654 into 10 to the power 12 second inverse. So the value of angular frequency is 5.654 into 10 to the power 12 second inverse. So I will need in another slide. So we know omega is 2 pi by t. Omega is 2 pi by t. That implies t equals to 2 pi by omega. That implies 2 into 3.142 divided by omega. Omega is 5.654. 5.654 into 10 to the power 12 second. So when we calculate it, sorry, today I am finding some issue with my mouse, that's why I can write properly. So 1.11 into 10 to the power minus 12. So the time period of rotation is 1.11 10 to the power minus 12. So the question was, what will be the average period of rotation for hydrogen chloride molecule if it is in J equals to 1 state, and we are provided with the internuclear distance of HCl, which is 0.1274 nanometer, and the mass of hydrogen and chlorine atoms are given also. So we know the rotational energy can be found out in terms of the value of J. Since we know the value of J here, we can calculate the rotational energy, and it is a square by 8 pi square I, J into J plus 1. So when we equate this, the rotational energy in terms of the rotational kinetic energy, that is half I omega square, then we can calculate the value of omega. So half I omega square equals to h square by 8 pi square I j into j plus 1, and equating it, omega will be h by 2 pi I j into j plus 1. So when you put the value of j here, it will be root 2h divided by 2 pi I because j equals to 1. So everything is known in this expression, but we only want to calculate the value of I because only then we can calculate the value of omega. So the value of I, we know the expression for moment of inertia is mu r square. So it is mu into distance, the bond length, the separation between two atoms square. So the effective mass of HCl is mass of hydrogen into mass of chlorine divided by mass of hydrogen plus mass of chlorine. So we will calculate this value because we know the mass of hydrogen and mass of chlorine. After that, by putting the effective mass here, and so effective mass will be how much? It will be 2.639 into 10 to the power minus 47. Sorry, I think there is some issue here. It is not. So the value of I is this much. So when we multiply all this, the value of I will be 2.639 into value of I will be 2.639 into 10 to the power minus 47 kg into meter square. So when you put all the values, omega will be 5.654 into 10 to the power 12 second inverse, and we know omega is equal to 2 pi by t. So the time period of rotation will be 2 pi by omega. So 2 into 3.142 divided by 5.654 into 10 to the power 12. So it will be 1.11 into 10 to the power minus 12 second. That is the time period of oscillation. So is it clear to you? So is it clear to you now? So that I can proceed to the next problem. So the next problem, it is given, calculate the wave number of the lines in the rotational spectrum of carbon monoxide for transition from 5 to 6 if the equilibrium bond distance of CO is 0.1131 nanometer. So this is similar to the questions we had solved in the previous session. So we want to calculate the wave number, and we know wave number is 1 by lambda. It has the same weight that of B. So the wave number is we know we know in case of transition, the wave number between transition from J to J plus 1 is equals to 2B into J plus 1. That is the higher of the two values involved. So in this case, what will be the wave number? Wave number will be 2B J plus 1 equals to 6, which will be 12B. But what is the value of B? Like in previous question, we calculated the value of B. B is 8 by 8 pi square IC. 8 pi square IC, and I is equals to mu r square. So when you put all the values, we can calculate the value of B. So B will be how much? 6.62 into 10 to the power minus 34 divided by 8 into 3.142 square into C is 3 into 10 to the power 8 into what will be the value of I? The value of I will be mu r square mu CO into r square. We know the effective mass of the effective mass of carbon monoxide will be mass of carbon into mass of oxygen divided by mass of carbon plus mass of oxygen into 1 mu. 1 mu is how much? So 1 mu 1.67 into 10 to the power minus 27 kg. So it will be 12 into 16 by 12 plus 16 into 1.67 10 to the minus 27 is 10. And after calculating the value of mu, when we multiply it with r square and r, we have the value of r is 0.1131 nanometers. So this is very similar to the previous problem. So when we put all the values, we can calculate the value of I, and when we put here the value of I, then we will calculate the value of B, and the wave number of the line in the rotational spectrum CO is 12B when the transition is from 5 to 6, because the wave number is 2B into J plus 1. J plus 1 is 6 in this case, that is the higher of the J value involved. So 5 from 5 to 6, the highest value is 6. So it will be 6 into 2B, it will be 12B. So when we calculate B here and put the value of B in the wave number relation, then we can get the value of wave number. So when we put all the values, so please verify the value of B will be 1.93 centimeter inverse, 1.93 centimeter inverse. So the wave number will be 12B, that is 12 into 1.93 centimeter inverse, that is 23.16 centimeter inverse. So this is the wave number of transition from 5 to 6. So when the transition is from 5 to 6, then this is the wave number of transition. So is it clear to you? This is very similar to the question we had discussed earlier. So in this case, uh, we only wanted to calculate the wave number of the transition from 5 to 6, and we know if the transition is occurring from J to J plus 1 in the rotational spectrum, the wave number of transition is 2B into J plus 1, that is it is proportional to the higher J value involved. So in this case, when the transition is from 5 to 6, the higher J value is 6. So it will be 2B into 6, that is 12B. And we know the value of B. The value of B depends upon the value of moment of inertia, and moment of inertia we have calculated numerous times. How to calculate the moment of inertia? It is effective mass into distance of separation square. Effective mass we can calculate from the mass of carbon and oxygen, and here it is 0.1131 nanometer. This is the distance of separation, that is r. So when we put all the values, we can calculate the value of B. The value of B will be 1.93 centimeter inverse, and when we put the value of B, so the wave number will be 12B, that is 23.16 centimeter inverse. So let's proceed to the next question. This question is the average value of spacing between The adjacent lines in the rotational spectrum of the diatomic molecule uh, Cx is 3.84235 centimeter. The equilibrium bond distance of Cx is 0.1131 nanometer. Find the atomic mass of X. So it is very much similar to the type of question we had solved earlier. What we will do in this case? So it is very similar. You can see the here, if you compare it with the previous question, the equilibrium bond distance was 0.1131 nanometer here, and it is 0.11 nanometer. So you can easily say that the value of here X will be oxygen only, that is X will be 16. 16, the mass number will be coming out to 16. So how we can calculate? We know, like in the previous case, the separation we were talking about. So wave number was 2b into j plus 1, 2b into j plus 1. Since here there are no j value given, so we will take the lower value. So the transition occurring from 0 to 1, in that case j plus 1 will be 1 only, so the separation will be 2b only. So here the value of 2b is this much. So we have 2b equals to 3.8423 centimeter inverse, and we know the value of b. The value of b is h by 8 pi square IC. When we put the value of b here and equate, the I is only unknown and I is mu r square, and in mu we know the value of c but we don't know value of x. So what we will write here? So x will take at, we will suppose x is the mass number for x. So in that case the mu of cx will be how much? It will be 12x divided by 12 plus x. This type of question we are solving the previous internal session, so you can refer to that also. So when you calculate it, you can easily calculate the value of x, and the x value will be coming nearly equal to 16. So the atom here will be oxygen only. So in this way you can calculate the atomic mass, because here the only trick is to understand this value, 3.84235 centimeter inverse is equal to 2b, because we know the separation between the separation, the spacing between the two adjoining line is 2b, because the lines are spaced like 2b, 4b, 6b, like that. So the separation is 2b only. So this 2b value is equals to the given value of 3.84235 centimeter. And when we equate this value by putting the expression for b, the unknown value is moment of inertia. And in moment of inertia, we can, from the moment of inertia value, we can calculate the mass of the atom, the atomic mass of x, because the bond distance of Cx is given and the only unknown is the mass of x. So the mass of x can be calculated when you put the value of x. Suppose x is the mass number of oxygen, then in that case in effective mass it will be 12x by 12 for 12x divided by 12 plus x, and x will be coming out, x will be coming out to be 16. That is oxygen. So the atom is oxygen and the molecule is carbon monoxide, that is CO. So finally, let's go to the next question. Now this question is again related to the rigid rotator. So here the wave number the wave numbers for the fourth and fifth rotational lines of HF molecule, which is a non-rigid rotator. So it is not of rigid rotator, it is of non-rigid rotator, at 164.0 centimeter inverse and 204.62 centimeter inverse, and calculate the centrifugal displacement constant d. So before this question what we are solving was of rigid rotator, but here in this case It is a non-rigid rotator, and for a non-rigid rotator, the separation between the separation between the lines, that is the wave number, is given as, if you refer to the lectures of the non-rigid rotator, we can found the wave number will be 2b into j plus 1, that is, it is of the rigid rotator part, and the additional part will be coming due to the non-rigid rotator case, because in case of non-rigid rotator there is another term which is j plus 1 cube, right? J is 0, 1, 2, 3, like that. So when uh, so here it is give the fourth and fifth rotational lines. So for fourth rotational line, that j value will be 3, because 3 plus 1 is 4. So here j will be 3, and here j will be 5. So the 1 will be 3 and 1 will be fourth and fifth. It will be 3 and 4. So j plus 1 will be fourth, and j plus 1 will be 5. Two, two, there are two transitions, so we will get two word number values. So one word number value, that is 164 centimeter inverse, what it refers to. So 164 is equals to 2b into j plus 1. It is 164 is for 4, and 204.62 is of fifth. So it will be 4, that is 3 plus 1 minus 4d into how much? 1 for 3 plus 1 cube, so it is 4 cube. So it is 3 plus 1 cube. So it will be how much? 4 into 2, 8. So it is 8b minus 4 cube will be 64. 64 into 4, 256b. 256b. So this 164 is equals to 256b. We got one equation, and another 204.62 is equal to 2b into 4 plus 1 minus 4b into 4 plus 1 cube. So it is 5 into 2, that is 10b minus 4 into 5 cube, 125 into 4, 500b. 500b. So 204.62 will be 204.62 will be 10b 10b minus 500d. So we have two equations and two unknowns, that is b and d. From these two equations, so you want to find the value of d. So please solve the two equations and tell me what will be the value of d. I will be waiting for few minutes, then I will calculate. So the two equations, when you solve, you can calculate the value of d. So we want to calculate the value of d here. In problem, it also it has also a centrifugal difference constant d. So please put all the please calculate, that is solve the two equations and find the value of d. So yes, the value will be 2.11 10 to the power minus 3 centimeter. So when we solve the two equations, what we will get, the value of d will be, so the value of d will be, so d will be 2.11 into 10 to the power minus 3 centimeter inverse. Units are always important, so the value of d will be 2.1 and 10 to the minus 3 centimeter inverse. So what we did in this problem, the question was the wave numbers for the fourth and fifth rotational lines of a of HF molecule, that is it is a non-rigid rotator. In the lines of first side 164.0 centimeter inverse and 204.62 centimeter respectively. And from these two values we wanted to calculate the centrifugal dissociation constant, that is D. So we know in case of a non-rigid rotator, the wave number of transition is given by 2b into j plus 1 minus 4d into j plus 1 q. So here b is the rotational constant like the previous cases, but here there is another constant d which is centrifugal dissociation constant. So when the bond between two is distorted, then there is mm, then there is a change in the energy levels of rotational level. So it is called as non-rigid rotator energy levels. So when we put the value for fourth and fifth rotation, for fourth rotation J is 3 and for fifth rotation J is 4. So when we put the value, so 164 is equal to 2b into 3 plus 1 minus 4d into 3 plus 1 q, and 204.62 is 2b into 4 plus 1 minus 4d into 4 plus 1 q. So when we solve the two equations, what we will get, the value of d will be 2.11 into 10 to the power minus 3 centimeter inverse. So let's proceed towards the next problem. Now this problem says the molecule HCl show a strong absorption of wavelength 3.462 micrometer. Assuming the origin of the line due to vibration, calculate the force constant of HCl bond. So now we will solve a few problems regarding the vibrational spectra. We solved problems in related to rotational spectra of molecule. Now we can come to the vibrational spectra. So here it is given the molecule HCl show a strong absorption of wavelength 3.462 micrometer, assuming the origin line due to vibration. Calculate the force constant. We know force constant. We know the force constant is K. That is when we in case of spring constant we uh, call K as spring constant. That is the energy is half kx square. So here, similarly, if you consider the force constant as k, then in that case, what will be the relation between force constant and omega? So omega will be k by mu root over. So this is a very familiar equation or familiar relation where omega is k by mu. So here we will calculate the value of k. So for calculating the value of k, we need the value of omega and we need the value of mu. So what is the value of k? So the value of k is uh, once again, if you convert omega into frequency, because here it is wavelength, here wavelength is given. So from wavelength we can calculate frequency. So from frequency, omega is 2 pi f. So omega is 2 pi f, where f is frequency, which is equals to k by mu root over. So 4 pi square f square will be k by mu, and k will be 4 pi square 4 pi square f square mu. So 4 pi square f square or nu square, and mu is the reduced mass. So since it is HCl, we can calculate the reduced mass. So the reduced mass of HCl will be how much? The reduced mass of HCl will be the reduced mass of HCl will be mass of hydrogen into mass of chlorine divided mass of hydrogen plus mass of chlorine. So the reduced mass of HCl can be calculated. So when you calculate the reduced mass, it will be coming out to be 1.63 into 10 to the power minus 27 kg. 10 to the power minus 27 kg, because the uh, if you calculate the reduced mass, it will be how much? Mass of hydrogen, 1, and mass of chlorine is 17. So 17 by 17 plus 1, that is 18, into mass of 1 mu 1.67 into 10 to the power minus 27. So it will be 1.67 into 17 by 18 into 10 to the power minus 27 kg. So which is equals to 1.16 into the minus 27 kg. So now we found the value of mu. Then what will the value of k? K will be 4 pi square nu square mu. But we have given with lambda, and lambda here wavelength is given. Wavelength is 3.462 micrometer. So we know it is 3.462 micrometer. 3.462 into 10 to the power minus 6 meter. When you convert wavelength into frequency, it will be how much? So nu will be c by lambda. So nu will be c by lambda, because frequency is velocity by wavelength. So when you put this, then the value of k will be how much? The value of k will be c square by lambda square into 4 pi square mu. We know all the values. C is 3 into 10 to the power 8. So 3 into 10 to the power 8 square. It is 3.462 into 10 to the power minus 6 square into 4 into 3.142 square into mu is 1.63 into 10 to the power minus 27. So put all the values and calculate what will be the value of k. So what will the unit of k? The unit of k will be Newton per meter. So the force constant is Newton per meter. So please put all the values. As we know all the values, we calculated the value of mu. Only that value is unknown, and we calculated the value of mu 1 into 17 divided by 1 plus 17 into 1 mu. So when you calculate, we will found the value of k if we put all the values. So please put all the values and tell me what will the value of k. So the value will be 483.20. So yes, the value will be somewhat close to that. The value what I have, the value is, so the value is 481 or 482. That's okay. That much of error is acceptable. So as a problem, the problem was the molecule of HCl shows a strong absorption of wavelength 3.462 micrometer. Assuming the origin of line due to vibration, calculate the force constant of HCl bond. So we know the force constant in terms of force, the relation between force constant and angular frequency with mass is omega is equal to k by mu root over. So only that, no, only because this relation is coming out in the form like we know it is half kx square, and this circular oscillator will half m omega square x square. So from this, if you calculate, k will be m omega square. So k will be m omega square. So m here, m is replaced by reduced mass because there are two molecules, the two atoms in a molecule HCl. So omega, when you put the value of omega is equal to 2 pi f or 2 pi nu and equated to k by nu root over, then k will be 4 pi square frequency square into effective mass mu. So the effective mass mu of HCl will be HCl 1 into 17 divided by 1 plus 17 into 1 mu 1.67 10 to the power minus 27. Then 1.67 into 17 by 18 equal to 10 into 10 to the minus 27 kg. So this value will be 1.63 into 10 to the power minus 27 kg. So we have given with the web number. Web number is 3.462 centimeter, 3.462 micrometer. So when you convert it into meter, multiply 10 to the minus 6. So this is 3.462 10 to the minus 6 meter. And if you calculate the value of frequency, then frequency will be velocity by wavelength. So it is 3. So when you put these values, so k will be c square by lambda square into 4 pi square into mu. So 4 pi square into mu. We know the value of mu, we know the value of lambda and c. So when we put all the values, k will be 481 nanometer. So let's proceed towards the next question. Now this question, Stokes line, anti-Stokes line. So this question is related to Raman spectroscopy or Raman spectra. We know in case of Raman spectra there are three lines. The center line, which has uh, the same frequency that of the incident line, is known as relay line, and the remaining two lines are Stokes line and anti-Stokes line. Anti-Stokes line has lower frequency, anti-Stokes lines has higher frequency, Stokes lines has lower frequency, and the intensity of Stokes lines is more than that of the anti-Stokes line. So here, with an with exciting line of 4,358 angstrom, a sample gives Stokes lines at 4458 angstrom. Find the wavelength of anti-Stokes line. So it is very easy. We can easily calculate the wavelength of anti-Stokes line. I told you there is a separation of anti-Stokes line. Yes. So in case of Raman spectra, what happens? There is the here it is the it is relay line, that is there is no change in frequency, but here it is Stokes line and here it is anti-Stokes line. So we know the wavelength of this line, we know the wavelength of this line, and we want to calculate the wavelength of this line, and we know here the separation between the two is 6b. Here it is 6b. When you consider the pure rotational Raman spectra, the separation between them is 6b, 6, where b is in centimeter inverse. So When you calculate it in terms of centimeter inverse, then we can easily tell where the anti-Stokes line will be happening or occurring. So in that case, here this is the value of nu zero or lambda zero, that is the central line, and this is of lambda Stokes. So this is in terms of wavelength, but when you convert it to wave number, then it will be 1 by lambda. So the wave number will be how much? Lambda 0 will be, so nu 0 will be, nu 0 bar will be 1 by lambda 0. So it is Armstrong. So for Armstrong, it will be, if you convert it into say, centimeter inverse, so it will be how much? 10 to the power 8 divided by 4358 into centimeter inverse, because 1 Armstrong is 10 to the power 8 centimeter into a minus 8 centimeter. So it will be how much? It will be 22946 centimeter inverse. So the central line is 22946 centimeter inverse. Now if you similarly calculate the Stokes line, then the Stokes lines will be how much? The Stokes lines will be, if you calculate the wave number of Stokes line, it will be 1 by lambda s, and 1 by lambda s means 10 to the power 8 divided by 4458. So here we are converting the wavelength to wave numbers, because we know the separation between them are equal in terms of wave number. So when you calculate the wave number, then it will be easier for us to calculate the, it will be easier for us to calculate the value for anti-Stokes line. So here it will be how much? 10 to the power 8 by 4458 into centimeter inverse. So it will be again 4, 2, 2, 2, 432, 432 centimeter inverse. So it is 22432 centimeter inverse. So one is 22432, another is 22946. So when you draw Raman spectra, this is the central line, this is Stokes, this is anti-Stokes. So it is in terms of frequency. When you consider frequency, then it is Stokes line, it is central line or relay line, and this is anti-Stokes line. But when you go in terms of wavelength, then it will be opposite, that is R, anti-Stokes R and Stokes. So here, as you can see, in terms of frequency, in terms of frequency unit or wave number unit, here the central line is at 946 centimeter, but the Stokes line is at 22432 centimeter inverse. So the Stokes lines is before that of the release line. So when you do in wave number limit, wave number unit, then if this is the spectra, then there will be three lines. This is Stokes, this is Rayleigh, this is anti-Stokes. The separation between two are equal. The separation between the separation between Stokes and Rayleigh and anti-Stokes and Rayleigh both are equal. So if we can found the separation between Stokes and Rayleigh, then we can easily find the separation between Rayleigh and anti-Stokes. So we can found the position of anti-Stokes. So what we found here, the relay line is 22946 centimeter inverse. So it is 22946. It is 22432. It is 22432. So what is the separation between them? So the separation between them is del mu bar, how much? 946 minus 432, it is 514, 514 centimeter inverse. So between them the separation is 514. So between these two the separation will be again 514. So when you add 514 to the existing value of relay line position, that is 22946. So 22946 plus 514, it will be how much? It will be 23460 centimeter inverse. So the position of anti-Stokes will be 23460 centimeter inverse, because the separation between Stokes and relay is equal to the separation between relay and anti-Stokes. So when we calculate first, it was given in terms of wavelength, but we here the wave number separations are equal, so we need to convert it from wavelength to wave number unit. So when we convert it from from wavelength to wave number, we found the position of the relay line is to 22,946 centimeter, and the position of Stokes line is 22,432 centimeter. So the separation between them is 514 centimeter inverse. So when again we add 514 with the existing value of 22946, then it will be how much? It will be 23460 centimeter inverse. So the wave number of anti-Stokes is 23460 centimeter inverse. So the wavelength of anti-Stokes will be how much then? Wavelength will be 1 by wave number. It will be 1 by 23460 centimeter inverse. So it will be how much? It will be 4262 Armstrong. So if you see here, we are considering in terms of wave number. So first there is Stokes line, then relay line, then anti-Stokes line. But if you compare the wavelength numbers, this line is 4458, this is 358, and this is 400 So in case of wave number, when you arrange, first will be anti-Stokes, then will be relay, and then will be Stokes. So if there is wave number, then Stokes line will occur at the lower value of wave number, then relay, then anti-Stokes. But in case of wavelength, first there will be anti-Stokes, then relay, then Stokes. So this is very important. These type of questions you get in entrance exams like net gate, just etc. So this concept is very important, and always remember to convert from wavelength to wave number limit, because we are familiar with the wave number limit. The spectra that we obtain are of wave number unit. So in wave number unit, the separation between them are equal, but in wavelength, the separation between them will not be equal, because if you say, if you are taking 2 plus 3, then it is not reciprocal. 2 plus 3 is how much? 2 plus 3 is 5. But if you say 1 by 2 plus 1 by 3 will be 1 by 5, then it is not true. So this so it is not. If you are considering in terms of wave number only, then you can say the separation between the two are same, that is the separation between Stokes and relay are equal to the separation between relay and anti-Stokes. But in wavelength limit, they are not equal. So in order to find the value of the position of these lines in wavelength limit, wavelength unit. So we will first convert the wavelength unit to wave number unit, and then calculate in terms of wave number unit, and it will and we will convert at last we will convert it to wavelength. So is it clear to you? Yes, you are right. So the anti-Stokes line is occurring at 4262. Always try to write the unit, because unit is very important. Unless you have the choices, like if you if there are multiple choice questions, then there will be units. So always try to always write the units. So consider the next question. The next question will be, so this is the question. This question is, the force constant of the bond in carbon monoxide is 1870 newtons per meter. Calculate the spacing between the vibrational levels in electron volt. Given the reduced mass of CO is 1.14 into 10 to the power minus 26. So here what we want to calculate? Here we want to calculate the separation between the two levels. We know the separation between the two levels is h nu. So if you can calculate the value of nu, then we can calculate the value of the separation between the two levels. And we know, in order to calculate the value of nu, we need to calculate the value of k. So the value of k is given here. The value of k is 1870 newton per meter. So as we had discussed, the frequency is how much? The frequency is, so the frequency is mu equals to 1 by 2 pi 1 by 2 pi into k by mu root over. So k is given. We want to find the value of mu. Mu value is also given, so we can calculate the value of frequency. So the value of frequency will be 1 by 2 pi, that is 2 into 3.142 into k is 1870 divided by 1.14 into 10 to the power minus 26 root over. So when you calculate, the value of frequency will be 6.45 into 10 to the power 13 second inverse. So the frequency is 6.45 10 to the power 13 second inverse, and we know the separation between the two level is h nu, because it is the energy separation. If the vibrational levels are denoted by V, then the separation energy, then the energy of the level is given by. So in case of vibration, it is 0, 1, 2, 3, 4 like that. So it is the separation is h nu. So the separation between the two levels, that is del E, is En plus 1 minus En. So the separation is h nu. We know the value of h. H is 6.62 into 10 to the power minus 34 into 6.45 6.45 into 10 to the power 13. So please calculate it and tell me what will be the separation of energy in terms of electron volt. So how many electron volt it will be. So what we calculated here. So the in question, the force constant was given and the reduced mass was given, and we need to calculate the spacing between the two levels in terms of electron volt. So So 427. No, no, electron volt. You want electron volt, it will be not, it will be very less, not 400 something. So if you calculate it, 1 electron volt is 1.6 into the minus 19 joule. So 1 joule will be 1 by 1.6 into 10 to the power 19 electron volt. So when you multiply here 19, then the value will be very less. So if you calculate, it will be how much? The value will be 6.45. The value will be 2 point, sorry, 26.7. So the value will be 26.7 into 10 to the power minus 2 electron volt, that is 0.267. In this value, if you divide by 1.6 into 10 to the power 19, then it is how much? 19 into 13, it will be minus 32. It will be 19 into 13 will be 32, 34. So only 10 to the power minus 2 will be remaining. And if you calculate all these, it will be 26.7. So the value in terms of electron volt will be 26.7 into 10 to the power minus 2 electron volt, or 0.267 electron volt. So this is the, then we can next question. So and this type of questions we had solved. So let me try a different type of question. This is very so since this is the last session, so we can discuss a few problems from the previous session. So it will be a revision to you also. So here the question is, the degeneracies of the J state arising from the 3p term with spin orbit interactions are. So the degeneracy of the J state. So you know, if the state is denoted by the if the state is denoted by J, then the degeneracy will be how much? The degeneracy will be 2J plus 1, is not it? So first we need to calculate what are the what are the values of J we will be getting if we solve the 3p term by spin orbit interaction. So if you consider the spin orbit interaction for 3p, here 2s plus 1 equals to 3. So s equals to 1 and l equal to 1, because l equal to 1 is for p and 3 is coming from 2s plus 1. Since 2s plus 1 equals to 3, since 2s plus 1 equals to 3, so s equals to 1. So in this case, since s equal to 1 and l equal to 1, j will be how much? J will be l minus s to l plus s. So it will be 1 minus 1, that is 0, and 1 plus 1 equal to 2. So it will be 0, 1 and 2. And we know if j is the quantum number, then the degeneracy is 2j plus 1. So if j values are given 0, 1, 2, then degeneracy will be how much? 2j plus 1 is 1, 2j plus 1 is 3, and 2j plus 1 is 5. Here it is j, here it is 2j plus 1. So the terms arising from 3p term is uh, j is 0, 1, 2. So if you write the terms, then what will be the terms? Then the terms will be for s equals to 1, l equal to 1, and j equal to 0, 1, 2. So it will be 3p 0, 3p 1 and 3p2. So these are the terms, and the degeneracy will be 1, 3, and 5. Similarly, another question. The degeneracy of an excited state of nitrogen atom having electronic configuration 1s2, 2s2, 2p2, and 3d1. So here it is uh, 3d1. So the 3d1 cell we will consider. So the for 3d1, that is d1, what is the value of L? For D, the value of L is 2. SPD value of L is 2, and there is only one electron. So for one electron, S is half. That is plus minus half. So when you calculate the value of J, then will be L plus minus half S. So when you do 2 plus minus half, then it will be 3 by 2 and 5 by 2. So since J is 3 by 2 and 5 by 2, then the degeneration will be how much? For j equal to 3 by 2, for j equals to 3 by 2, 2j plus 1 will be how much? 2j plus 1 will be 4, and for j equals to 5 by 2, 2j plus 1 will be 6. So total degeneration will be 10. So for 3D1, we have L equal to 2 because it is d sub cell, and there is only single electron, so the value of S will be half. So S can be plus half or minus half, so the value of J will be L plus minus half. So 2 plus minus half, that is 3 by 2 and 5 by 2. So from 3 by 2 the degeneracy is 4, and from 5 by 2 the degeneracy is 10. So it is 4 plus 6 equals to 10. So the degeneracy will be 10. So I think we have uh, time's up. So thank you for joining in today's session. All the best for your exam. Do you have any doubts? You can ask me. Okay, so all the best for your exam. I hope you are appearing for the exam on 30th April, I think. So thank you once again. Uh, all the best.